How you guys doing? So I have finished CNC machining the base here, and if you've seen the previous video, it is this base here. So this one was a 3D printed prototype, and then this one was CNC machined. So on the top here, we have a nice shiny look to it. It was kind of a bit of a challenge to make this part because if you notice, it's not just flat, so it does have some shape to it. And on a 3-axis CNC machine like this, that was not exactly trivial, so that it did involve using some 3D printed fixture plates such as this. So this one gives me the setup for machining the very bottom. So if we flip this over, this surface here, so that way I could machine all that flat. Looks like the acrylic cracked, so I'll have to look at that. And yeah, well, that's the way it looks like on the inside. It's not perfect. You can see over here, especially in those slots. So that was second issue. First mistake I had here was trying to restart some G code after it failed on me. And that was due to a chip hitting the switches over here. I believe it was this one, switch 0. And that just triggered the whole machine to stop as it was machining. So I definitely got to start putting covers on this and this one over there, and same with over there. The one on the Z-axis on the back, it's deep in there, so it's less susceptible, but I'll probably have to put like a hood or something up there. Yeah, so yeah, good idea. If you have to stop a program, then you're best off just trying to modify the G code. Yeah, well, I didn't have any success with it. So the other thing was slotting. So it's easier to see from this side here. Pick any of these slots. It's actually harder to tell on this side because of the, there we go. Yeah, so what I did was I used a 3.1 millimeter end mill, and it was pretty long to get down there because it had to be like at least an inch or so just to get past this big chunk there. And yeah, there was a lot of flex, and slotting is just really sucks. So that's the result I got. Lots of burrs and crap, and it looks like yeah, I don't know. Like it looks like it's melting it a little bit. Plus, on the spoiler, on the spoil board, we can see over here, that's one of the slots. So I think also what happened was it got really dark due to just milling into the spoil board, and then just like the friction just blackened it and turned it all to hell. But other than that, everything worked out pretty good. The acrylic piece in there, it's surprisingly very tough stuff. I thought it was going to be very flexible. Mind you, it is like it's there was supposed to be a 0.2 millimeter gap in there, but you know, after machining it, it ends up being like 0. So the this kind of crack that just formed, looks like this one's also forming, so I'll have to look at that. That might be due to just how pressed in there it is. But yeah, I'll have to remachine that. But yeah, that's the overall look of it. So I'm still not done machining this. If you notice on this one, there is no holes there. And then on this one, it's hard to hold this thing. So we have 2 USBs, and then that's an area mount. So 1/4-20 threads, and then 2 small, I think 3.2 millimeter holes beside it. I tried using like an M6 single tooth thread cutter to mill that thread, and I just couldn't get deep enough, and I didn't want to just expand the hole. I'm just kind of concerned about if it is strong enough. So I decided to just buy a thread cutter specifically for that, and I'm just going to wait and then machine that out. And yeah, machining this involves some 3D printed fixture plates, which worked out pretty good. The machining of this, how I went about it was not perfect, so I'll kind of show you what I started out with. So first setup was machining just the shape of this from a rectangle and just getting that shape. And then I flipped it over, and then you can see on this side, you can basically mill everything here and then do like 3D adaptive ops for like getting just like the angle and everything. And once I was done, I then used this yellow fixture plate and put it like that. And this gives me the 6-degree angle to mill that flat. And then I had put a piece of copper there just to get the level correct, just because 3D printed stuff, it just doesn't line up very well. So that actually worked really well. So did that, and then realized after machining it, I had to do all the chamfers and all that stuff, especially around the holes here, because I didn't do those originally when I did the facing. So originally I just did the facing and then did the perimeter. I never milled out any of those holes. What I should have done was I should have milled all those holes out on the first setup, and then that way I wouldn't have to have gone in with the slotting. I could have just used a really small little 2mm end mill and just mill out those, and I wouldn't have any problem with that. Plus all the chamfers would be lining up. This one over here didn't line up so well. It's there, it's smaller, but you can see on the other ends, it's not very noticeable, but like it would be good if I could get all the chamfers like perfectly aligned. So that was a bit of a challenge, but you can see over here, like this chamfer went in after the fact, and it did all right. The surface looks pretty good. So what I had to do for that was, after machining this side and then machining the off the fixture, flipping it over, I had to use this, go back and use this fixture plate here, and then this one was just to lift this whole thing off, because now I had the bottom of it no longer flat. So this got me the flat surface, and then I could use that to mill in all those chambers. So yeah, overall this worked pretty good. The only thing, as I said, mill that in, and then that's done. And then I have to mill another base altogether to get the rest of this done. And so far, these fixture plates worked really well. This one over here is the last fixture plate I have to do, and this ends up going to be a 90-degree one. So that's just going to get me an ability to mill that on the side. And what I'm thinking of doing is just it's just those holes. So I'm thinking of just probably mounting it over here in the corner, having it below the table, and then that way I can easily get over there. And yeah, it's like hanging off, and this is about 1 inch of MDF, so it's probably gonna do a bit of wobbling stuff, but it's really light cutting, so I don't think it's gonna be too much of an issue. So the material was 6061 aluminum, and it came out of another block of aluminum like this, and this is 1 inch thick. And it didn't give me a lot of space if I compare the ends, but you get the idea. Like there's maybe like 1 millimeter gap in there. So yeah, it couldn't easily hold anything in the vise. So I ended up just using the tape down method with super glue and holding it all in. And that worked really well. Like I didn't have any issues milling all of this. Like there was some holes that I could, in theory, bolt it down, but like I had to mill all the way down to get to them, and like those were basically the last operations, so there wasn't really much of a point to it. It was light cutting. I couldn't really do deep cuts because I didn't want this whole thing to be thrown off due to just the hold down method. For surfacing the top plate, I used a BAP 300R and a PCD insert. So you can see over here, that's a CBN one. Hold on a sec. There we go, PCD. So that's the one I use, APK 1135. That worked really well. And doing like 0.1, 0.2 millimeters, and just basically just surfacing this until I machined it all. And yeah, at least on my machine, it gives a really nice result. Like you can see, it's got nice rainbow effect. My spindle tramming is probably not that great. You can see the lines very clearly defined, but like aesthetically, it does make it look nicer when the machine marks are not like totally mishmashing into each other. So I'm okay with that. BAP 300Rs are usually come when you order them. They're really long, and they're like probably like 6 inches long or so. But if you stick them in a drill press and hit it with a grinder, you can just grind it away to the size you need. After I'm done machining the right side, I want to try and tackle machining the clusters and the keys again. I did try and machine these before and had some success, but they are very small parts, and I need to rethink some of the operations and how they turned out. Most of the milling you'll see in later in this video is predominantly done with single flute DLC coated end mills, such as this is a 6mm, and I did use a 3 flute DLC like this, the same one, and I did use this for the perimeter, so getting the outside surface. And I didn't have a 6mm 3 flute because I wanted to use that on the inside walls, and I ended up not being able to do that. I attempted using a 3 flute, and that was the result. Yeah, 3 flute end mills like this, no coating. They're basically useless if you're not using like MQL or any sort of active cooling in aluminum. They just heat up too quickly and they just destroy everything. So there's really, yeah, at least for me, I can't find any use for these. The bigger ones like this one, they can absorb tons of heat more, and the coating is very slippery to aluminum, and these things don't have an issue that I find, at least just like doing cleanup of perimeter walls and stuff. These work fine. For machining all this, I use a collet fan, and for this job I made a special one. I use a DLC coated one for cutting aluminum. That's why it's all shiny. That's why it's all shiny compared to these tools. So this one works a lot better on aluminum. But I do have a MQL system. I just don't have it set up on the machine. This is just some kind of brand on AliExpress. Didn't cost anything, and it just comes with some other components. But I will have to get this on the machine eventually and try that out. But I do like using the collet fan just for, especially when recording videos, because it just blows all the chips and everything away. And because everything's dry, there is no issues of chips sticking and just throwing stuff like that. And also, you like alcohol, you're not dealing with fumes of things, which is nice. And these things are really cheap to make. So the keyboard itself is great. It's Svalboard. It's very, very kind of different than a regular keyboard. I've got my CNC machine over here. Obviously, this is not really a keyboard, but it functions the same as one. Yeah, like if I was gonna design a keyboard without knowing what a keyboard looks like, when you look at our hands, like it's gonna be something like that. Like that's ergonomic. You got buttons on every finger, minimal motion of getting to your fingers and stuff. Like this is what a keyboard should look like as an interface for a computer for humans with hands like this, compared to something like this, which is. But yeah, if you're interested in this keyboard, it's called the Svalboard, and just there's a website where Morgan sells these things. You can buy it as a DIY kit where it comes with all the PCBs, circuit boards, and just basically all the parts that you need, minus the 3D printed parts. And if you got a 3D printer, you just print the whole thing, and you get all the files to print it. And it's great. Like if you break anything, you got the parts, you got the design to change it and make replacement parts and all that stuff, which is nice. So cut to milling this, and you can see what the operations look like, and see how it was going and all that. And I might do a voiceover because my voice was not that great that day. So it almost finished the roughing, but we got a error. Joint 0 limit switch. I think joint 0 is my X, which is over there. But yeah, it's almost done. That's what it looks like so far. Very shiny. So this is the results after the roughing of the 6mm DLC. And so far pretty good, except I did make one boo-boo over here. You can probably see it where I cut into that. So the next operation is to run an 8mm 3-flute end mill around the perimeter and just clean it up. The quality is a little bit rough, so we should make it look a little nicer than that. So that was the sides done. You can see all the corners are nice and smooth now. So that's what it looks like there. And then on the side here. So we basically got to do the same thing on the inside now, because all of the perimeter walls, we can see all those vertical lines there. So let's just run the adaptive clearing from the 6mm. So now we're going to run a 3-flute 6mm. This is an 8mm. And we'll just clean up the rest of it. And just how the part looks like after the chamfers have been put in. So they've been put around all the perimeter walls. Here's the results after machining the inside. So if we flip it over, you can see that I already pre-machined that side already. So the next step is to mount in the fixture plate, and this will get me a flat surface, and then I can machine all these little ridges down flat. Let's see how they look. And then also I need to machine these holes for the feet, and then also these ones here. These are for holding an acrylic sheet in. This is the next setup. So it's now in this 3D printed fixture plate, and this gets me the angle I need so I can mill that surface nice and flat. And my G54 is the center between this face and the opposite one, and then over here. So that way, like if the if this is off ever so slightly, like the chamfers when I go in should be a lot more centered now, instead of like one side being too thick and another side not being as thick. So I've zeroed that in, and I'm gonna run an 8mm flute and duck this off and then go from there. The part after the chamfering on the top. I really should have put in all these features originally on the surfacing, because, for instance, milling these with a 2mm, like a short one, would be a lot easier if I didn't have to go through the bottom and like have like almost an inch of offset. So, but it turned out all right. And now the final part that I have to put in features is in the front for the USB-C and the airy mount. All right, thanks for sticking around to the end of the video. On the next video, I will probably be working on milling the smaller components of this, the keys and the clusters. Clusters are the rectangular shapes, and it's mostly gonna be trying to figure out like the cam, all the operations, how to hold everything down and all that, because these are very small components. So thanks for watching the video, and I will talk to you guys in the next video.